Good evening, everyone, and welcome to today's masterclass titled Connecting the Dots of Computing and Data Science Through Speech Recognition. We are thrilled to have Dr. Mariya Celin with us today. She's Assistant Professor, School of Computing and Data Science at Sai University, and also a passionate educator and researcher in speech processing, machine learning, and NL. Uh, Dr. Mariya holds a PhD degree from Anna University, has published a speech corpus with Linguistic Data Consortium at the University of Pennsylvania, and holds a patent for speech assistive aid designed for individuals with cerebral palsy. Her work has appeared in reputed IEEE journals, and she has taught and mentored across institutions where she leads courses in natural language processing and computer architecture. Please join me in welcoming Dr. Mariya as she takes up this exciting journey. Thank you. Ma'am, over to you.
A very good evening to everyone present here. So today's session, we'll be trying to connect the dots the dots in the sense, the courses that you're going to do from the School of Computing and Data Science through speech recognition. Okay. So we'll go through every courses and how it is being related to a problem called as speech recognition. So in order to start that, you first try to understand what speech recognition is, and then we'll try to bring up few courses that will help you to connect this particular platform. Okay. So to start with, first let's try to understand the first phrase, meaning what is speech recognition. Okay. The next slide, please. Okay. So I hope most of you would have used Alexa, Google Voice Assistant, or Siri for that matter. So that basically recognizes your speech and performs a particular task. It recognizes speech, converts into a text, and that text is then performs some task for you, right? Works as a voice assistant. So the major target of any speech recognition system is to convert any speech form into its textual format, right? Now I've given an audio file. Can you please play that?
Welcome to Sai University.
So this was the audio file that is played, and the recognition system gives you a text. Whereas in case of Alexa or Siri or Google Voice Assistant, it does some tasks for you on the other hand, right? Now, it might sound simple for you that I'm just trying to map some audio file with some text through some dictionary or through like, if you want, I could say that through some traditional programming. But then what we essentially do here is what we will do. We will learn how all the other courses are linked in this case of building this particular task of converting any audio file into a textual format. Okay. So for the next file. Next, please. Okay. Now, if I want to start this particular task, say for instance, I'm doing it only for my voice, which means it's going to recognize only my speech data and it's going to give some textual format for that particular speech data, what I am speaking. In that case, what is the predominant thing that's essential for me? The predominant and the most essential one is the data. So what I do initially is to do this task. Remember, what is your task? Your task is to do a recognition, which means converting your speech into a textual format. So that's my major task. So the other dots will come here in order to help as a supportive measure, and that is going to be that is going to act as your course for your 4-year degree program in your BTech in School of Computing and Data Science. So essentially, first job, what you will do is you will try to first collect. Now, in case my task is to recognize my speech data, whatever that I speak, I want to recognize. So in that case, I'll collect my audio recording in order to recognize the speech. So say for instance, I've collected few audio files of say for the number 100, and but I've recorded here and there as somewhere perfect and somewhere imperfect. Some I've recorded in a noisy environment. Some had few glitches I had. But I've done some data collection of my audio file, but I'm not sure about how good the quality of my audio is. So first what I'll do is, once I created the audio, I want to work out about the analysis of my audio. That is, I want to work on the analysis of my data. Next. Okay, so these are few samples that I collected. I would like to play that for you. If possible, you can put in the chat box telling that what are the differences that you find in all of the 3 audio files. Okay, the first one,
Welcome to Sai University.
The second.
Welcome to Sai University.
The third.
Welcome to Sai University.
Okay. I would expect in the chat box that somebody could reply what are the differences that you find in all the 3 data files that essentially that I collected. Anybody could reply on that, like what are the 3 differences that you find out, or what are the differences that you find out in all the 3 audio files that you listened right now? Okay. Fine. Okay. So basically, okay, there's no response. That's fine. So the first audio file which you listened was basically a very clean audio file that gave you the perceptual quality was really good. But in the second audio file which you listened was more of noise, and in the third audio file it was not very much sparse, but then it was sparse here and there, which means there was cut off at certain points in the audio file. Okay. So this is the quality of data that I have collected. Okay. Now, likewise, I had almost like 100 samples of this particular data, right? So what is my aim? My aim is to develop a speech recognition for my audio to convert some audio file into a textual context. For that, my first step will be to collect the data, but I randomly collected the data without having any pre-notion about how should I collect the data. So some data were really good, some with noise, and some were like with few glitches and was I mean, the audio quality was very bit poor. So what is my first preliminary job is to declutter all of this data and understand how much are good, how much is bad, and what should I do with the bad data. Okay. So the next. Okay. So this is where the first step of your data analysis and visualization begins. So what you do here is, with all of the piece of data that you have, you try to, I have just taken a very naive assumption about calculating the amplitude. I see that in the case of my noisy data, the amplitude is very high because of too much of noise influenced in that. Whereas in the sparse and in the clean data, I could see the amplitude is okay, but still it says that the sparse and the clean data are almost the same with the same level of quality. So what I have to do is, but when you hear, you understood that the first audio and the third audio are entirely different. The first audio is very much clean, but whereas the third audio had glitches here and there. So I have to go for another. So this is one indicator, but this was not giving you a very good, it was not able to categorize it very well. So what you'll do is you go further step and try to understand if there's any other way or any other possibility in order to identify what is that dissimilar between all of the three pieces of information. Next. Okay, I tried to draw a pie chart. So now with what information I'll try to draw is the difference between the first volume of first audio signal and the second audio signal is, in the first audio signal, it was very clean, telling welcome to Sai University. In the second audio, it was like, so there were some void spaces in between. So this will help. What will be the ideal factor that will help you to differentiate the first and the third audio? Calculating the silence regions, right? In the third audio, you had too much of glitches telling that there is more silence regions, and in the first audio, comparatively a lesser. So I tried to draw a pie chart to show how much amount of silence regions is there between the two audio. Okay, these are all very naive explanations to in order to help you to do the decluttering. Okay, next. Okay, so in the same way, I also tried to put a box plot about how the amplitude is being distributed across the clean and the sparse data. Okay, so these are all few visualization techniques that will help you in order to classify the volume of data that you have. Okay, in my case, it is audio, but as in the course, you will be working with numbers. Okay, so you will be working with numbers in order to identify about the errored information values and about the good quality of numbers and what to do with all of these numbers. You try to plot, you try to do visualization in order to do the decluttering process through visualization techniques. Okay, next. Okay, now I try to understand that something is wrong with the data that I collected. I try to do the similar process for the entire piece of information that I collected. And I try to draw a plot telling that the red dots telling those are the data that's very sparse, yellow telling that these are the data that's very noisy, green telling that these are the piece of information that's particularly very clean. So what I'll do next further is I have visualized, I've understood some portions of my data are good, some are very bad, and some are like sparse. So what I do the next step is whether should I proceed with that noisy and the sparse piece of data. Okay, so for example, you cannot directly delete that entire data. Okay, because deleting an information is like you're going to, at the end result, you're going to lose the quality of that particular model that you're going to develop. What is your aim? Your aim is to convert my speech into some text, right? If you're losing few pieces of information because of its quality, then on the end that you will end up with having no data at all. So what you're supposed to do is you will try to do something with the data that you have. Clean, you don't have to touch anything. It's okay. It already looks fine. When it comes to noise, what are the other opportunities that you can do? You try to reduce the noise. Okay, so that the speech quality is much better. And when it comes to sparse data is like something like you have a picture where in the entire piece of picture, some pixels are missing. So what do you do? If suppose, for example, a very close by pixel is missing, then what do? You try to repeat that same pixel in the next particular frame. So in the same manner, for the sparse data also, for the void spaces, you can try repeating the same frame again. Okay, in order to not totally remove the particular data, or otherwise you can just use a small weight of that particular data in your modeling part. Okay, so what have you done in the first step now? So the target is basically to convert speech to text. In that, your first step was to analyze and sit and analyze with the data, identify what is the useful information, what was very bad in the data. If it is bad, what am I supposed to do further with that bad piece of information? Should I actually neglect that information or should I work on it in order to improve it further, right? So this is my first step in order to do my first task on speech recognition, right? So for this, you took the help of data analysis and visualization. Okay, next. Okay, yeah, this is the same thing that which we spoke now. Next. Okay, now I have decluttered the data. I had noise, I had clean, I had sparse. The noise I removed, I used some filtering techniques and I tried to reduce the noise. I cannot remove, I tried to reduce. I made it somewhat closer to the clean. Sparse, I tried to repeat the same frames and made it somewhat intelligible. Now, the point is I have one good volume of data, but it's all audio. So what can I do further in order to convert my audio to text? So with just signals, I cannot move further. So what I'll do now is I'm done with signals. I've done proper analysis with that. I now have a good piece of information of audio signals. Now we're not going to carry forward the audio all the time. So I'm going to convert all of my audio into numbers, because with the numbers. So what I'll do, my next step is I'm just leaving my audio behind, and all the information that I have in my audio, I try to convert it into numbers. So how do I convert it into numbers? So now say for instance, how do I do that is, I should know what is the useful piece of information that will represent that particular audio. Say for instance, you're going to an airport to pick up somebody. So you don't know who is that person. Somebody will tell you that this person will look tall, he'll wear this color jacket and he's having this color suit and all of those pieces of information. So what is that? That is the prominent feature of that particular person, right? In the same way, I don't want to carry the audio always with me. but I'm just going to take the representatives of my audio. That is the prominent feature of my audio that will best represent what that particular context is being spoken. So I take all of that piece of information through a lot of mathematical operations like Fourier transform and all of that, but we are not going to go deep into that. But in a very naive explanation, if you want to say what that numbers is I am saying a word hi, hello. The way in which the science which involves my speech production, through that I try to develop those numbers because that is the best representative of my audio file, right? So with that science, I try to develop what the numbers are. So I leave behind the audio. Now it's all that is there with me is numbers. Okay, now with these numbers, I want to develop the text. What is my aim? My aim is to develop my speech into text. The first step was to collect audio. Though I had my audio, the audio was not fine. I did few analysis and visualization techniques in order to declutter my audio. And once the audio file is all ready, now I decided that with signals I cannot do much. So I'm trying to convert them into numbers. To convert them into numbers, I take all the prominent features that best represent that particular audio. And with that numbers is what I'm going to move forward. Okay. Now, once I have all of those numbers, I'm going to introduce few math concepts. That is, we will be using linear algebra, prob and stats in order to do the modeling part. Okay. Next. Next, please. Okay. So where are we now? Till now, we had audio signals. Then we extracted features. I've just listed few features that represent the audio. We don't have to go deep into all of that. And now you have a number representation of that audio file. With that number representation, you have to find out the pattern. Now, a simple example of how to do pattern recognition is what I'm trying to tell is, now say for instance, I have 2, 4, 6, 8. So what is the most probable number like that's going to occur? The next one is going to be 10. So how did you find out that the next number is going to be 10? Because you looked at the pattern in which the previous numbers have occurred. In the same way, I will look at the pattern in which each sound is being produced and that is being mapped to some label. Like for instance, welcome to Sai University. So I try to understand what are the numbers that will represent this particular phrase. And with that, I try to develop a model, right? Next. Okay. Now from the patterns, now we move to the next part that's called as learning. Here we will be using the machine learning concepts. The very simplest and naive representation of putting up machine learning is, I've just put it up a linear set of linear equation like y is equal to f of x, where x is nothing but your numbers that you extracted from the audio files, which means the prominent features. And f is nothing but the model. And y is nothing but what that respect to x is going to be. Now in our case, x is nothing but the audio, the numbers of the audio file, welcome to Sai University. And F is nothing but the model that has captured the prominent patterns with respect to that respective audio. And Y represents the text, meaning the text of welcome to Sai University, the textual format, right? So this is a very, very simple explanation about what exactly we do at machine learning. We try to give examples and ask the machine to learn rather than writing a traditional set of programs, putting up a lot of switch cases or putting unnecessary if and else conditions. We try to give a lot of examples and ask the machine to learn through examples, right? Now, here, as I mentioned in the previous slide, I said that 3 math concepts will be useful here. One is your linear algebra. Linear algebra will help you to do the modeling part. Number 2, the probability. Probability will help you to take decisions. Decision in the sense, though you have modeled, you have to make up a decision telling that in future, if some audio file comes in this particular pattern, I have to, in what probability will I tell this belong to this particular text? Okay. And then you have statistics also being involved, where statistics will help you in taking up the performance measures and all of that. Okay. Next. Okay, so this, whatever that I explained about the three components of math is what I put in here. So in order to do the entire piece of modeling, so all of your three math concepts of linear algebra, probability and stats will be involved. Okay, so X is nothing but your audio piece of information. F of X is going to be your model, and Y is going to be the textual content of what that audio belongs to. Okay, next. In the technical terms, you have labels and otherwise the supervised learning. We're not getting into too much of the learning concepts, and just trying to touch all the aspects of the courses that you will be doing in computing and data science. Okay, now your task is done. So what was your task? My task is to convert any speech to text. So for doing that, you pulled in a lot of math. You pulled in machine learning, initially you pulled in data analysis and visualization, all of that. There's one person missing, we'll see that person later. Now, say for instance, I initially built a system to recognize only my speech. Now, say for instance, I want to recognize all of your speech data. Then I'm not dealing with just hundreds or 200s of numbers, but I'm dealing with millions of data. So how am I going to work with that millions of data? Is that same concept of just doing with linear algebra and all of that stats and prob, will that alone be helpful? No, you're going to bring in another concept called as deep learning. So what you do here is you do a better learning where you try to mimic your biological computer, which is your human brain, how your brain learns. Based on that, you try to do the learning here, giving the loads of data here. Giving all the loads of data that you have collected for all of us, and try asking the digital computer to learn from that big volume of data. So here, important math concept that will be utilized is calculus. This also comes in hand with another concept of subject called as optimization theory. So what do we do here is, I'm giving loads of information to this connected neural network and asking it to tell in future if somebody speaks like this, it should say this is the text that he has spoken. So initially when I give him the volume of data, it will not immediately tell the right answer. For example, I'm saying something and you are standing way away from me. You will try to listen to me. You will try to say, okay, is this what you said? Even if you're wrong, I say, no, I did not say that. I try to louder my voice, or I try to tell it 3 times, 4 times. Then you grasp what I've said and you tell this is the text that you spoke. So how did you do that? You gave you listened to my volume of data. I mean, my piece of data, and then you try to relearn, and then gave the proper text that was spoken by me. In the same way, this does. First, it makes mistakes. Then it tries to adjust. Then it tries to give the right prediction or right answer for that particular test data. So this is what you do on a very big model of deep learning. Here, you will be using the concept of optimization and calculus. Now, I told you that I will give a volume of data, you make mistakes, then you adjust. So who's playing the major role here? The one who adjusts. Because if it's not adjusted properly, then many times, even after you repeat the data many number of times, it's not going to say you properly. Like for instance, I'm shouting 1,000 times also. If you're not listening to me, you will never reply properly. In the same way, you have to adjust in the way so that you get back the right answer. So for the concept of this adjusting and learning the data properly is where this calculus and optimization theory will help you. Okay. So for this, you will use the math trick of differential calculus. And also this, on the other hand, as a whole, you will be doing it in optimization theory. Okay. Now, a very naive example out to explain on how calculus and optimization theory will come into play is, now say for instance, you have, this is what regular examples they give. You have a hill. This particular hill is going to be your error, the top of the hill. And you have a ball. The ball is actually your speech recognition system. Now, if my ball is on the top of the hill, what is top? The most highest error. That is the most highest mistakes it has. It has to somehow come down to the bottom of that particular hill in order to make it as a perfect speech recognition model, right? So the ball has to roll down to the end of that particular hill. So how do I do that? That direction in which am I supposed to adjust? All of that is what you do in differential calculus. So what you do, you basically calculate the slope. Slope will tell you the direction in which you are supposed to move in order to reach the end, which means a perfect model. Okay. And apart from this, all of this you're going to do it in a computer, in a digital computer. So, and I'm also talking about volumes of data. So you need to understand also the computing infrastructure about how a computer does a job, which means how a computer understands an instruction, responds to the instruction, or how it parallelizes all of that instruction and does the job. So this is what you will study in computer organization and architecture. And since you're dealing with large pieces and volumes of data, which means it is going to do multitasking and a lot of jobs to be done, all of that you will do in database management systems, and the compiler design will also come into play because you're supposed to write codes in human language, and it has to be converted into machine language. So you're also doing subjects on compiler design as well. Next. Okay, so how did we start this process? We had to do a speech recognition system. We had a very small data because I want the recognition system to just recognize only my speech of data. So I had a very small data. I did a very basic machine learning process. Then I thought, okay, let me try to also recognize everybody's speech data. So more speakers were involved, more data were there. I want to bring up some generalization. So I tried to mimic my biological brain. That's my human brain. And for which I incorporated deep learning, and I used the math trick of calculus and optimization in order to reach a best solution. Okay, next. Next. Okay, so what have you done till now is you had some volume of data, you know you had to adjust something, and then you adjusted it. But there could be some case that you will not even know where you're standing. That is, you just have volume of data, you'll not even know what you're supposed to do. In that case, you will use a technique called as reinforcement learning, where in reinforcement learning, you're learning through mistakes or you're learning through rewards, which means I'm training a dog. I cannot tell the dog, okay, go read the dog theory book and do behave discipline. No, I cannot do that. I'll tell the dog, put some instruction. If it does the instruction, does the job well, I give him a reward, give him some bone or something. If it does not do it well, then in that case, I give him a punishment, like I'm not going to give him a food for 10 minutes or 15 minutes. I'll make him wait for 10 or 15 minutes. So by this, it will try to learn how to behave in a disciplined way, or how to how to behave in a disciplined way. So which means here basically I have a large volume of data, but I don't even know where my hill itself, which means where am I standing itself, I don't know. If you don't know that, you'll not even know where to go down or go up, nothing you know. So you just have piece of information, you have to do all the decluttering and all of that. In that case, you will use a concept called as reinforcement learning. Next. Okay, so where are we now? We started with speech recognition, where I want to convert some speech into some textual content. First, I wanted data. I want to declutter, for which I use data analysis and visualization. And then I had to start with machine learning. Then I did a few deep learning. For all of this, I took the help of math. And then we did optimization theory. And then you did reinforcement learning. Now, all of this was able to give what the particular text was spoken. Now, there could be some case where I will have very low volume of data. And there could be a scenario that you cannot create such data from them at all. For example, medically conditioned data. Medically conditioned, if that is the resource I have for that data, then that is a resource. I cannot create more than that data. then in that case, you try to move from discriminative learning, which means identifying or predicting what the label is, to a generative learning where you try to create data itself. So you classify as well as you create it. That's what you do in generative AI. Okay. So how the graph has been moved? I had small volume of data. I did machine learning. I had large volume of data. I did deep learning. And if you want to do classification as well as if you want to generate a data, then you go for generative AI techniques. So this will also play a role in your data scarcity issue. So from tweaking, you have gone to creating data. Okay. Next. Next. Okay. So when I was discussing all of this, I just tried to avoid one single course that was about programming, because programming is the only thing that is going to act as a glue for all of these courses. Okay. But in that case, this is not going to work like as I said before, it's not going to be some traditional programming like, okay, if this is the audio, this is the label. If this is the audio, no, you're not going to write anything like that. On the other way around, you're going to teach the machine about the patterns that you have learned in the data through math and through your logics. Okay, to build a lot of intelligence systems. So apart from all of these courses, you will also be doing programming courses, which is going to be the binding factor for all of the courses. Okay. Next. Okay, so I have explained about speech recognition, but then this particular piece of information can also be extended to text in case if it's going to be on natural language processing, images in case if you're going to do on computer vision, or videos, or even with finance data, or with any piece of data that you can think of. So that is where a lot of interdisciplinarity will come into play. So all of this, what you have studied, you can bring that, all those pieces of information, you can do any kind of modeling if you have a data with any interdisciplinary matter through this technique, through this way. And the one person that's going to gel everybody is the program. Next. Okay, so this is the final picture about how do we connect all of the dots. I've just listed few of the courses that you will be doing, but there are also other courses which I have not mentioned, like the compiler design I have not mentioned here. And also, yeah, you will also have, you're doing networking courses, because just if I build a speech recognition system and just have it with me, it's not going to help anybody. I also need to transfer, I also need to put it in real time and all of that, where networking will also play a role that will help you in sending and receiving that piece of information. Okay. So yeah, that's it about this entire uh, talk on connecting all the courses through speech recognition